Okay, we are asked on this problem to find where the graph of the function has horizontal tangents. So here's something important to memorize or to think about, really. If you have a graph, right, and the graph has a horizontal line, something like this, okay, what can you tell me about the slope of that line? Okay, the slope of that line is 0. Therefore, when we're asking about a function and whether or not it has a horizontal line, what we're asking is, where does the derivative, we're asking if it has a horizontal tangent, we're asking where does the derivative equal 0. So what we're going to do is we're going to use the limit of the difference quotient. So we don't know exactly where this is going to occur, so we're not going to look for a particular point per se. What we're going to do is we're going to just solve it. We're going to use x, some arbitrary variable x. Okay, so when I do that, all right, when I do that, I'm going to plug in x and I'm not going to look back. So we're going to do that. And in this case, I'm going to write out the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Okay, so what does this look like? Well, I've already got f of x. What does f of x plus h look like? Okay, this looks like this. 4 times x plus h square plus 5 times x plus h plus 2. All right, that's f of x plus h. And there's some work that you can do. The binomial expansion, really, you'd have 4 times, and then the x plus h square is x squared plus 2hx plus h squared. There we go. Looks like that. Okay. And then we can do the distribution here. Plus 5x plus 5h plus 2. We do some more distribution. Of course, we're going to subtract f of x. So minus 4x squared plus 5x plus 2. And divide all that by h. Now, one thing I'm forgetting, and it's very bad of me, is the limit as h approaches 0. That's so important. You have to keep writing that. Okay, the limit as h approaches 0, and now I'm going to distribute the 4. 4x squared plus 8hx plus 4h squared plus 5x plus 5h plus 2. And then I'm going to distribute the negative there, minus 4x squared minus 5x minus 2, all divided by h. All right, now we're ready to cancel some stuff here. Cancel or combine like terms, I should say. 4x squared cancels with a negative 4x squared. 5x cancels with the negative 5x. A positive 2 cancels with a negative 2. Oh my gosh, this is so nice. Okay, we are left with this limit as h approaches 0 of 8hx plus 4h squared plus 5h, all divided by h. And now we can reduce that, or divide out or factor out the h that's in the denominator, and that's going to leave us with 8x plus 4h plus 5. And so what we have found here is that since h is approaching 0, we are going to be left with 8x plus 5. All right, this is actually really cool, because this right here is the functional derivative. The functional derivative, whoa, that didn't come out right. The functional derivative. All right, and we denote the functional derivative with this right here, f prime of x, and we read it f prime of x. What does that mean? The derivative of f of x. So let me just get to this. If f of x was 4x squared plus 5x plus 2, its derivative f prime of x is 8x plus 5. Now I'm going to tell you there's some relation between these two things here. All right. I looked at the problem and I knew it was going to be 8x plus 5 right away. See if you can figure it out. There's rules for this that'll make this a lot easier. That you don't even have to do the difference quotient, but that's a discussion for another time. Let's continue. We are concerned with where does this derivative equal 0. So this is quite easy because it's just a linear equation. 8x plus 5 equals 0. Subtract 5. 8x equals negative 5. We divide by 8. This equals 0 at x equal negative 5 over 8. And what we're going to do is we're going to find, well, where's the point? Because that was the question, I think, at the very beginning. Find the points. So we need an x and a y. Okay, so there's actually only one point. And in order to do this, we have to find f of negative 5/8. All right, so what does that look like? That's going to be 4 times negative 5/8 to the second power plus 5 times negative 5/8 plus 2. All right, I will let you figure that out. But yeah, you could use a calculator, I suppose. 7/16 is where it happens. So the point negative 5 over 8, 7/16, that's the x and the y, if you will. This is the point where we have a horizontal tangent. All right, this is where the slope of the tangent equals 0. All right, so not much to it there. You know what they say in the infomercial, but wait, there's more. So let's take a look at another problem. This next problem is slightly more challenging. Again, we're asking where does this graph have horizontal tangents? Again, we're asking where is the slope of the tangent equal to 0. We're asking where is the derivative equal to 0. So I'm just going to fast forward through this really quickly. I am going to solve it, don't worry, but I'm going to tell you right away what the derivative should be. All right, it's going to be this, 3x squared minus 9. Okay, but let's go ahead and prove it. All right, the limit as h approaches 0 of f of x plus h minus f of x all divided by h, and let's see what that looks like. It's a lot of fun. If you've seen one of my previous videos, it was like 30 minutes long. I go into Pascal's triangle. I'm not going to do that here. All right. Yeah. X plus h cubed minus 9 times x plus h minus x cubed minus 9x all divided by h. And let's go ahead and just do the binomial expansion really quickly. There is a trick, a binomial cubed trick to figuring that part out right there. So that's what I'm going to do. All right, but yeah. Okay, it looks like that. All right, that for sure is it. I'm going to do the distribution there. Minus 9x minus 9h. And then more distribution, minus x cubed plus 9x. All divided by h. And then let's see if we can get rid of anything. Minus 9x plus 9x. X cubed and a minus x cubed. And I think that looks like it. All right. The limit as h approaches 0, I have 3hx squared plus 3h squared x plus h cubed all divided by, oh wait, and I'm also missing a minus 9h. I see it now. Minus 9h all divided by h. All right, now I'm going to divide out the h, factor out the h. All right, let's see what I'm left with. 3x squared plus 3hx plus h squared minus 9. Okay. Yeah, that goes to 0, that goes to 0. And what am I left with? 3x squared minus 9. Ironically, that's what I told you it would be. Way back up over there. Well, is it voodoo or something? No, not at all. It's just you got to know the rules. But maybe by now you've figured out how in the world to do this really quickly. There's some rules, they're coming. Right now you got to learn how to crawl before you can walk. Okay? So let's see. Now we're concerned with where does this equal 0, right? We're concerned with where does it equal 0. So I'm going to solve this, let's say using the square root principle, square root property. I can add 9 because you could do that. I mean, this is one of those quadratics that's really easy to do. Like that, solve it like that. Okay, x squared equals 3. You take the square root. The only thing is you got to remember x equals plus and minus 3. So there's actually two places where the tangent equals 0, and it's actually quite nice. So what do? We plug it into the original so that we can, oh, shoot, I just remembered, it's the square root of 3. We plug it into the original so that we can get the two y values. And so let me write out what f of x was again. It's x cubed minus 9x, okay? So we're going to find f of the square root of 3, and then we're going to find f of negative square root of 3. So I hope I've given myself enough space here. All right, let's go ahead and check this out. So I am going to have the square root of 3 cubed minus 9 square root of 3. All right, and then here a negative square root of 3 cubed minus 9 times the negative square root of 3. Looks something like that. And what happens here is that I end up with a square root of 3 cubed, which is square root of 3 times square root of 3 is 3, times another square root of 3 is 3 square root of 3, minus 9 square root of 3. That gives me 6, negative 6 square root of 3. Okay, the next one is very similar, but it's negative 3 square root of 3. All right, plus 9 square root of 3, because negative times negative, and that ends up being 6 square root of 3. So my 2 points where I have a slope of the tangent equal to 0 are the square root of 3, next negative 6 rather, square root of 3, that's my x and my y, and negative square root of 3, and a positive 6 square root of 3 for the y. And this is where the slope of the tangent equals 0. So that's where it has horizontal tangents. Okay, so otherwise a really nice problem. Really nice problem. It's a lot of algebra. It really is a lot of algebra in calculus. So I hope this video was helpful. And as always, like and subscribe.